so now we're going to look at independent and dependent events. Now, there's a lot of probability. They can be disjoint but independent, or, I mean, there's going to be a lot of the stuff that's the same, but we can call each event different things, independent, dependent. So a lot of what we're going to be doing, the examples, we might have to use some of the formulas for probability from 10.4 and 10.3. Okay, so it all kind of mixes together. So just kind of what I gave you at first to start with at the top of your paper is just the definition of probability again, all successful outcomes over all possible outcomes. And then I wanted to define independent and dependent events. So independent events means that the outcome of one does not affect the outcome of the other. So independent events could be like if we're drawing marbles out of a bag, but we put the marble back, we'd want to draw two. After we draw the first, we put it back. So if I drew a blue one the first time, that doesn't affect what I could possibly pull out the second time, right? Because the blue one goes back in. Yeah. Dependent events are events where the first outcome affects the second one. So if I have my marbles, and they're all different colors, and I draw a blue one first, but I don't replace it, now that changes the entire probability of drawing a blue one a second time, right? Yeah. Because there's one less blue one. So that's just two examples of independent and dependent. So we're looking at the probability of independent events first. So the probability of independent events happening, the first outcome does not affect the second. When we want A and B to happen at the same time, we just multiply them. So it's the same as disjoint ands. Okay, probability of dependent events, we've actually already done examples of this. We just did not call them dependent events. We want both of them to happen, and we're multiplying, but we multiply the first event and then the probability of the second event after the first event already occurred. So if I'm drawing marbles, that changes the denominator, right? Because there's one less. It was like the CD problem. Okay, so dependent events, every time your probability is changing, the amount you have to choose from is decreasing. Okay, so remember I just wrote another note and I am going to box it and put a star next to it. Be careful. Okay, if a problem uses the word and, multiply. If a problem uses the word or, add. Okay, so it says it right there for you. Box it, put a star, bring your attention to it. Okay, so and is multiplication, or is addition. So let's look at example 1. Example 1, all we want to do is identify if it's independent or dependent, so we have to practice first. So if I have, let's use independent blue, dependent purple. Okay, the color of a car selected at random and the type of transmission selected at random. Does one affect the other? No. So are these independent or dependent? Independent. Okay, so I could select a blue car and transmission number 1. You know, like it doesn't matter which car I pick for the transmission. Okay, what about B? A letter of the alphabet selected at random and then another selected at random. Is that independent or dependent? Independent. It can be either one, right? It depends. If I select A and now I can't pick A anymore, does that make it independent or dependent? Dependent. If I select A and I can put A back and select it again, is that independent or dependent? Independent. So this question's not really super clear. It can be either one. So just write. So we have independent or dependent. Okay, this one is not a super clear question. Okay, what about C? This is a good one. Completing your homework and earning a good grade on the test. Independent or dependent? Dependent. If you do your homework, you are more likely to get a good grade on your test. Okay, what about rolling a die and getting a 1, and then rolling it again and getting a 3? Independent. Not too bad, right? Okay, so example 2. A card is to be selected from a deck of 52 cards. What is the probability that it is a black card or a 10? What do we need to do here? What's the word, or and? Or, so am I going to be adding or subtracting? We're going to be adding. Okay, what's the probability that it is a black card or a 10? Is there overlap there?
Yeah.
There is. How many black 10s are there?
2.
2 black 10s. So we need to first find the probability of pulling a 10. What's the probability of pulling a 10? 4 out of 52. Plus, what's the probability of pulling a black card? 26 out of 52. There's 4 10s, but there's 2 black 10s. And how many black 10s are there? 2. So we have to subtract 2 out of 52. Because we counted those 2 black 10s twice. Okay, so that gives me 4 plus 26, 30, minus 2 is 28 out of 52. And then we can reduce by 4. 4 goes into 28, 7. And 4 goes into 52, 13. So that is 7 out of 13. What is this called again when there's overlap? Non-disjoint. I'm going to write off to the side. Non-disjoint. Okay. So this is what I mean. Now everything is just going to start mixing together with our probability, and we have to decide what type of event it is. So, step 3. Okay. A drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and then replaced. So we take one out and then put it back. Another paper clip is taken from the drawer. What is the probability that the first is red and the second is blue? What's the word, and or? And are these independent or dependent events? I take one out and then I put it back. Does the color that I pulled the first time now affect what I pulled the second time? No. No, so they're independent, right? So let's find the probability. Let's actually write that here too, independent. Okay, just so that we know. So what's the probability of pulling the first one as red? 3 out of 3, 7, 5 is 12. So actually, let's write that here, 12 total. So the probability of pulling a red is 3 out of 12 times, right? What's the probability of drawing a blue? 5 out of 12. Okay, so that gives me 3 times 5 is 15 over 12 times 12? 144. Okay, both of those reduce by 3. 3 goes into 15, 5, and 3 goes into 144, 4, that's 12, and 24, 8, 48. So 5 over 48. Independent. Yeah? Still good? These are similar to what we did like the first day, right? Kind of. Yeah, yesterday's, or yeah, the first set. Okay, what about 4? A drawer contains 3 red paper clips, 4 green, and 5 blue, so that's 12 total. 1 paper clip is taken from the drawer and not replaced. Another paper clip is taken from the drawer. What's the probability that the first is red and the second is blue? Okay, so the first event does affect the second event, right? So these are dependent. Okay, dependent events. Okay, so what's the probability that the first one we pull is red? 3 out of 12. We had all our paper clips to choose from. The word is and, so is that addition or multiplication? Multiplication. Okay, so I took one paper clip out and I didn't put it back. So how many total do I have to choose from now? 11. And what is the probability that that one's going to be blue? 5, because I didn't pull a blue one the first time, right? Okay. Instead of multiplying straight across, let's reduce first. 3 over 12 reduces to 1 over 4. This is going to be a lot nicer. 1 times 5 gives me 5. And 1 times 4, or 4 times 11 gives me 44. This doesn't reduce anymore, right? So the probability is 5 out of 44. Okay. Let's look at example 5. You have 10 coins, 3 dimes, 5 quarters, and 2 pennies. How many coins is that total? 3 dimes, 5 quarters, 2 pennies.
How many
Coins total. 10, right? I have no idea. I didn't notice that when I typed this out. Let's change it just to 2. I don't know why I did that. Okay, so a coin is selected and replaced 3 times. So I pull a coin and then I put it back, and I do that 3 times. Find the probability that all 3 coins are dimes. Okay, so is that an and or an or if I want all 3 to be dimes? The first one is a dime, and the second one is a dime, and the third one is a dime. And so it's multiplication or addition? Multiplication. Now let's think about this. Is this independent or dependent? This is independent because I put the coin back, right? Okay, so what's the probability of drawing a dime the first time? 3 out of 10 times. I put the coin back, so what's the probability of drawing a dime the second time? 3 out of 10 times 3 out of 10 equals 3 times 3 times 3, 27 over 1,000. Does this reduce? No. Okay. Okay, so B, a coin is selected and not replaced. So it's going to be dependent. Find the probability that all 3 coins are dimes. So is this or and still? It's still and. Okay, so we want the probability that the first one is a dime, and the second one's a dime, and the third one's a dime. So and or? And, so we're going to multiply again. So what's the probability of the first coin being a dime? 3 out of 10. Times 2 out of 9 because I pulled a dime the first time, so there's only 2 dimes left and 9 coins to choose from. And then what about the third time? 1 out of 8. Yeah, you're right. We can reduce 2 and 8. 2 goes into 2 once. 2 goes into 8 4. We can reduce 3 and 9. 3 goes into 3 once. 3 goes into 9 3 times. We could have reduced 2 and 10 also, right?
Yeah.
Doesn't matter. So what's on top? 1. Okay. Let's do 3 times 4 gives me 12 times 10, 120. Not good odds, right? Okay. Example 6. John is choosing between 2 majors in college, either architecture or engineering. His preference in each area is shown below, and that's the chart. If the probability of him choosing architecture and commercial architecture is 72%, what's the probability that he's going to find what's the probability that he's going to pick engineering? Okay, so first we need to find his probability of picking architecture, and that will help us find his probability of picking engineering. Okay, so here's the chart. Make sure you draw the lines in, so that it should make the chart should make a little bit more sense. So let's think about this. If he is going to for sure pick architecture or engineering, that means that both of them should add up to what percent? 100, right? If he's going to either pick architecture or engineering, they should both add up to 100%. Let's say he picks architecture. Now he has two choices between residential or commercial. Which one does he like better? Commercial, right? But 10% plus 90 still gives me 100.
Yeah.
So if he picks architecture, now he has two choices, and those should add up to 100. If by some chance he picks engineering, he has two choices between mechanical or electrical. Those two should add up to 100%. Which one does it look like he likes better? Electrical. Now the only thing we don't know is, does he like architecture better or does he like engineering better? Because it makes a difference. So let's look at part A. We want to find the probability that he is going to pick architecture. Let's call that X. Okay. What did we know about architecture though?
It's 72%.
The chance that he's going to pick architecture and then pick commercial is 72%. Okay, but if he picks architecture for sure, he's 90% going to pick commercial, right? Does that make sense? Okay, so if the 90% chance that he's going to pick commercial, 0.9, 90%, times the chance that he's going to pick architecture should give me 72%. What type of event is this? The probability that he's going to pick architecture and commercial. Independent or dependent? Dependent, right? He can't pick commercial unless he picks architecture. The word is and, so we're multiplying. So we multiply the chance that he's going to pick architecture times the chance that he picks commercial and architecture. Does that make sense? Okay, so how do I solve this for X? Divide by 0.9. So X equals 0.80. Or, how many percent? 80%. So what's the probability that he's going to pick architecture? 80%. So if he has an 80% probability of picking architecture, what's the probability he's going to pick engineering? 20.
So we could have done engineering.
Alright, so we have a company here called PAL Distributing, and here's all of their employees. So they have 9 men working for them total. 7 of them are college graduates, and 2 of them are not college graduates. For women, 12 of the women are college graduates. 3 of them are not college graduates, so there's 15 women total working for them. And then we totaled up 19 college grads total, 5 non-college grads total, and 24 employees total, right? Okay, so that's all the chart is telling us. So, we want to know what is the probability that if you randomly pick an employee, it will be a female, given that you pick a college graduate. So are these independent or dependent? Dependent, because I know that I picked a college grad first, right? Okay, now this is called a conditional probability, so let's underline that. Meaning that I want to pick a female college grad, and I was told right from the front that I did pick a college grad. So of all the college grads, what's my probability of picking a female one? There's a formula for this. We don't need the formula. Let's just use our brains. Okay, I gave you the formula. We don't need it. Okay? So this is called a probability of event B given event A. So I want B to happen after I know that A already happened already. On your notes, when I typed it out, the automatic formatting changed it. It should be probability of B and then that long slash A. This long slash means given. So there's a shorthand for this, the probability of B given A. Here's the formula. Like I said, we don't need it. So what are we looking for here? We're looking for the probability of pulling a female given what? What were we given? That she's a college grad. So given college grad equals. Okay, what do you guys think we could do here? How many college grads are there to choose from? 19. That's going to go on bottom. How many women are college grads? 12. That's it. I'm serious. Example 8. So in this one, it's a similar type of problem, a conditional probability, but there's not a table given to us, so we're actually going to have to use our brain power a little bit. If the probability of event A given event B is 0.6, so how would we write that first? Probability of A given B is equal to 0.6. And the probability of event B is 0.4, so probability of just B happening is 0.4. What is the probability of events A and B happening together? Okay, look at this right here, this part. Do I know 2 of the 3 things that I need for this? I know this part, and I know this part. So what can we call this part?
X.
Let's just call it X. Okay, so the probability of B or of A given B is 0.6. So 0.6 equals. Do I know the probability of A and B happening together? No, so we're calling it X over. What's the probability of just B happening? 0.4. For this one, it's B given A. In the formula I gave, the problem says A given B. We're fine. The letters are just switched. Okay, yeah, don't worry about it. It's not always going to be A and B in this order. Okay? If it's switched, you just switch them. Yeah. How do I get X by itself? Multiplied times 0.4. So that's X equals 0.4 times 0.6, 0.24. So what's the percentage of A and B happening together? 24%. Does that make sense? You guys okay with just for the problem they gave it to us A and B switched?
Yeah.
Okay.